So I wanted to reach out and show you some solving equations. I'm actually going to see if I can get through both lessons from this week, because it's all about solving equations. So there's a couple of things. When you are solving equations, it's all about kind of working backwards. This piece right here is probably one of the most important things. When we're talking about the inverse, we're talking about addition and subtraction because they undo each other. So like if I give you $4 and then I take $4 from you, that's a +4 and a -4. You still end up with $0. And I'm just being mean because I gave you money and then I took it away. So that's the same thing with multiplication and division. If I multiply by 2 and then I divide by 2, I end up at the same spot. Okay, so let's just do some of these examples here. So if you notice, it says x minus 4 equals 13. So when we are trying to balance this equation, we're trying to get x by itself. So consider it like it likes to be alone. It's like more of an introvert. And right now this clingy little -4 is staying with it. And so I need the -4 to go away. So I need it to go to the other side. So I'm going to add 4 so that I can get rid of it. So that's the inverse. And so whatever I do to one side, I have to do the other side. So I would add 4. And then if you notice, it says x equals 17. You can always check your work by plugging it in. So if I plug in 17 for x right here, 17 minus 4 does get me 13. So another one down here, we have 5 plus x. So right now I'm trying to get x by itself, which is a variable. A variable just means a letter that stands for a number. So we're trying to figure out what does that number actually mean. So when I take away 5, whatever I do to one side, I have to do the other side. And if I only have $3 and somebody says, give me $5, I still owe them $2, which is why it's a -2. Okay, let's do a couple of more of these. So we have x plus 7 equals -3. So here we would take away 7 because that's the inverse of addition. Whatever I do to one side, I have to do the other side. 7 minus 7 is 0. So if I add 0 to your pocket, I've done nothing. So we just cancel it out. And I'm left with x equals. Now, if you remember my song, same sign, add and keep. Well, these are the same sign because they're both negative. So we would add 3 plus 7 and we would get 10. And we would keep the sign, that negative. So x would equal -10. And you could plug it in to see if that's true. I should get -3. Well, now I have different signs. So same sign, add and keep, different signs, subtract. 10 minus 7 is 3, and there are more negatives. So that is a -3. That does check out. Now, it doesn't matter that the variable's on the other side on this one. It really does not matter at all. We're still going to solve it the same way. I'm still trying to get w by itself, and it's attached to this -6. So the inverse of -6 is a +6. And whatever I do to one side, I have to do the other side. And when I say side, I'm talking about the equal sign. So whatever I do on one side of the equal sign, I have to do the other. Woo! I cancel out. I'm left with w equals, and we have different signs. So same sign, add and keep, different signs, subtract. So 7 minus 6 is 1, and there are more negatives. So it'd be a -1. And we can know that this is true because a -1 plus a -6 does get me -7. Check. So then we have a division problem, okay? And we know this is division because it has this little line right here. If you remember, it kind of looks like a division symbol, okay? It looks like a division symbol. So when I'm working through these division problems, I would do, oh no, what's the inverse of division? Hopefully you're saying multiplication. So I'm going to multiply both sides. I'm going to multiply both sides by whatever the variable's attached to. And if you notice, that would be the -4 right here. So I'm going to multiply by a -4. I end up canceling that out and left with A equals a negative times a negative. We did this when we did that little mad cat. A negative times a negative gets me a positive, and 4 times 20 is 80, so positive 80. And that makes sense because 80 divided by a negative 4 would get me a negative 20. Check. So we've done an adding, a subtracting, a dividing, and now we're going to do a multiplying. Now you might be asking, how do I know this is multiplying? Well, because remember, if they're close together like that, that means to multiply. So you can add the little dot if that helps you to remember. And remember, the inverse of multiplying is division. So I'm going to divide by negative 16. If you want to put the little division symbol instead of the line, that's okay. That still means the same thing. This cancels out. And P would be 48 divided by 16, which if I counted up 16s, it would be 16, 32, and then I would get 48. So it'd be 3 groups. Ooh, there we go. And a positive divided by a negative is a negative. And that makes sense because negative 16 times 3, negative 16 times a negative 3 would get me a positive 48. So that does actually check out. So there is this code for you to practice. This one's not for a grade because we do have a weekly assignment. I do want to show you the 2-step equations, which we are doing today on Friday. So it says solving 2-step equations. We're either going to add or subtract first, then we're going to multiply and divide. So this means that I don't just have the one operation, I have 2 of them. Okay, so we're going to actually have to get rid of the addition and subtraction first. So it's almost like you're doing a reverse PEMDAS. So you're going to get rid of the addition and subtraction first, then the multiplication and division. So in this case, if you notice, they subtracted first, canceled out, it came down to 3x. A negative plus a negative is a negative, same sign, add and keep. Then they're like, oh, this is multiplying, so the inverse is to divide. And they got negative 7. And then they just checked their work. Again, here's another one. We need to get x by itself. Well, we need to get rid of that adding 30 by subtracting it from both sides. Then we would be left with negative 18x equals negative 180, because they were both negative here. And then you divide by negative 18. Okay, so on this one right here, I need to do reverse PEMDAS. So I'm going to subtract 5, cancel it out. 11 minus 5 is 6. Ooh. 2m equals 6. So this is multiplying. So the inverse of multiplying is dividing. Cancels out. So m would get me 3. And then you could check your work by saying 2 times 3 is 6. 6 plus 5 is 11, which is exactly what I wanted to get. Okay, so this one looks a little bit more challenging, okay? So we look and we go, okay, I've got a subtracting and I've got a dividing. So I need to do the subtraction first. So I'm going to add 7 because that's the inverse of a negative 7 is a positive 7. So now I'm left with d divided by negative 3, because that's still there, equals 13 plus 7, which is 20. And since this is division, the inverse of division is multiplication. And so I would multiply by negative 3. And I would end up with d equals, a positive times a negative is a negative, and 20, 40, 60. So this would be a negative 60. Ooh. And if I plug it in, Negative divided by a negative is a positive. 60 divided by 3 is 20. And 20 minus 7 is 13. So it does check out. Okay, again, we have a subtraction. So we're going to do the inverse of subtraction, which is addition. Whatever I do to one side, I have to do the other side. Same sign, add and keep. Different signs subtract. So 10 minus 8 is 2. And there's more negative, so it's going to be negative 2 equals, we have left over here is negative 2r. So I'm going to take a negative 2 and divide it by a negative 2, which is just 1. That's just 1. Last one we're going to kind of go over is this weird one. It's so weird. Okay, let's start with the part that's not super weird, which is go ahead and subtract from both sides because you're trying to get x by itself. Okay, now this is where it gets weird. This is multiplying by 2/3. So really what's happening is we have to divide by 2/3. Okay, now if you remember, we don't divide fractions. We have that little cute little song that says dividing fractions is easy as pie. You flip the second number and you multiply. Well, we have to do that here. Dividing fractions is easy as pie. You flip the second number and you multiply. So we are going to still do that. And then 4 times 3, remember if you're multiplying fractions, you just multiply the top times the top and the bottom times the bottom. 4 times 3 is 12. And 1 times 2 is 2. And then 12 divided by 2 is 6. Ooh, that's supposed to be a 6. 6 equals x. And then you can always plug that in and say, okay, 2/3 times 6 over 1 plus 8 should equal 12. So that would be 2 times 6 is 12. Ooh, that's a 12. 3 times 1 is 3 plus 8. Well, 12 divided by 3 is 4. 4 plus 8 is 12. So yay, bam. That's supposed to be a check mark. Check. It's a check mark, I promise. Okay. And then if you really want, what I really want you to do is practice 6/6R, that's two-step equations, but you do have a weekly assignment. It is 5 questions. It is a review of everything we've done so far. So please make sure that you go get that done first because that's the one that's going to be for a grade. And if you have any questions, please feel free to ask. On iExcel, when you do something wrong, remember it always gives you the reason why and what to do. That's the bell. So class is over. Have a great day.